Okay, so let's talk about naming cycloalkanes. The IUPAC rules for naming these cyclic compounds are much simpler than when we're naming linear compounds. There's really only two rules that we need to remember. The first is to find the parent, and the parent can be cyclic or it can be linear. It's just going to be the piece with the largest number of carbons. So here we have 1, 2, 3, 4, 5 carbons in a ring and then a methyl substituent. So we're going to name this with the parent as the ring. Now it has 5 carbons, so we're going to name this as a pentane, but we want to indicate that this is a cyclic molecule, so we're going to call it cyclopentane. That's going to differentiate it from linear pentane. We only have one substituent here, and it's a methyl, so we're going to name this methyl cyclopentane. And so we're not going to call this methylpentane because we need to indicate that the parent is a ring. We're also not going to call this 1-methylcyclopentane because that would be redundant. No matter which carbon this methyl is on, it would be carbon 1 because there's only one substituent. We'll see in a couple of seconds multiple substituents. Okay, so let's do another example. The ring isn't automatically the parent. So consider this example. The ring is a 3-member ring, and we have a 4 carbon chain here. So we're actually going to name this as a butane. 1, 2, 3, 4. At carbon 1, we have a cyclopropyl. So the substituent is a ring. It has 3 carbons. It's made up of 3 carbons. We call it a cyclopropyl. The YL indicates that it's a substituent. We only have the one substituent, so we're ready to give the full name. So this is 1-cyclopropyl butane. Okay, when we have more than one substituent, we need a second rule. And the rule basically tells us to number the substituents to give the lowest locant. So let's consider this 6-member ring. It's going to be the parent. And so we're going to name this molecule as a cyclohexane. Okay. And now we have to give a locant to the 2 methyl substituents, and we have a choice. The correct way to do this is by giving the lowest locants. So if we start at this methyl, 1, 2, 3, we see both of our substituents, a carbon 1, 3, dimethyl, 4, 5, 6. So we're going to name this 1, 3 dash. We're going to combine the substituents because they're the same, dimethyl. That is all the substituents. This is not a hexane, it's a cyclohexane. So we have to indicate that. So we would number this 1, 2, 3, 4, 5, right? Not 1, 5, because those are higher locants. And as a rule of thumb, if you add up the locants, 1 plus 3, 4 versus 1 plus 5, 6, you're going to get the right answer when you pick the lowest sum. Okay, so let's do a tri-substituted. So let's do a heptane, so a 7-member ring. See if I can draw this correctly. There we go. We have an ethyl, we have a methyl here, and another methyl here. I have, well, the first thing is find the parent. So obviously it's the ring because it has 7 carbons. Make this a little neater here. So we're going to name this as a cycloheptane. And it's going to be a cycloheptane that has a methyl, and an ethyl. If I start numbering at this methyl here, 1, and continue to the ethyl, 2, I'm going to get the lowest locants. 1, 2, nothing at 3, carbon 4, nothing at 5, 6, or 7. So I'm going to have a 1-methyl, a 2-ethyl, a 4-methyl. So 1, 2, and 4. Okay, I'm not going to do this. I'm not going to name this as a 1-methyl, 3-ethyl, 4-methyl. Right? Not as a 1, 3, 4. Right? Because those locants are higher. Right? These add up to 7. These add up to 8. So the name for this molecule, we have a 2-ethyl. I'm going to combine the methyls in a 1, 4 dash dimethyl. Those are all of my substituents, so now I'm ready for the parent. The parent is a cycloheptane. Okay, so let's just do a couple more examples. The heptane was a little funny looking there, but that's a 7-member ring. 5 and 6-member rings are going to be very common. So during practice problems with 5 and 6-member rings is going to be really useful, especially the 6-member rings. We're going to spend a whole lot of time talking about those. So we have a 5-member ring here, so immediately it's going to be a cyclopentane. We have an ethyl and we have a methyl. We're going to name this as a 1-ethyl, 2-methyl cyclopentane. We really cannot forget that cyclo there. Okay, the substituents don't just have to be alkyl substituents. We can have halides. Okay, so let's do an example with a halogen. So 4-member rings are not as common, but we can still apply their rules. So this would be the parent, cyclobutane. We have a bromo and a methyl. Now, we can number 1, 2 starting at the bromo, or we can number 1, 2 starting at the methyl. So we do need to kind of address that a little bit. We're going to go by alphabetical order. We're going to give 1 to the bromo and 2 to the methyl, just by convention. Actually, up here that would be the case too. 1 for the ethyl and 2 for the methyl, just for alphabetical purposes. So this is going to be 1 bromo, 2 methyl, that's the last substituent, cyclobutane. Okay, let's do a tri-substituted cyclohexane. It's going to be a bromo. Okay, bromine starts with B, so it's often going to win. And when we're putting these substituents in alphabetical order, we have a methyl and an ethyl. So no matter which substituent we start numbering at, we're going to have a 1, 3, 5. Right, 1, 3, 5, or here 1, 3, 5, 1, 3, 5. Okay, so we're going to give the bromo the 1. 1 bromo. Then we have to choose between the ethyl and the methyl, because they would, either way we go, it's going to be 3. We're going to give the ethyl the 3. Again, we're going in alphabetical order. And then lastly, the 5 for the methyl. So here's a scenario in which no matter where you start numbering, you're going to end up with the same locants, 1, 3, 5. So we're going to number them in alphabetical order. 1 bromo, 3 ethyl, 5 methyl cyclohexane. So let's write that out. 1 bromo, dashes between numbers and letters, 3 ethyl, 5 methyl, that's my last substituent, is a cyclic parent, so cyclo. It has 6 carbons, so hexane, cyclohexane. If we have complex substituents and we know the names, we can use the name for the complex substituents. So let me give you an example here. Okay, so the parent here is going to be cyclobutane. This substituent there, if we start numbering the carbons, carbon 1 is going to be the carbons for the substituents. Carbon 1 is going to be the carbon that's directly bonded to the parent. So 1, 2, 3. So the substituent is going to be a 1-methyl propyl. Okay, we would put that in parentheses and then put it with the parent. So 1-methyl propyl cyclobutane. Now maybe we recognize that that complex substituent there is sec-butyl. So we can just name this sec-butyl and then the parent, cyclobutane. And again, there's only one substituent of this ring, so I don't need to call this 1 parentheses 1-methyl propyl close parentheses cyclobutane. That would be redundant because there's only one substituent. If I had another substituent, if I had, for example, the bromo somewhere on here, I would, actually let's go ahead and do that. So I'm just going to do the same substituent there, and then I'm going to put a bromo here. Okay, the bromo is going to be 1, and then the complex substituent is going to be 4, because no matter, 3, because no matter which way I start numbering, they're going to be 1, 3. So I'm going to name this 1-bromo, and then I'm going to list the substituent. So 3, open parentheses, 1-methyl propyl. Okay, there's my complex substituent. That's my last substituent, so I'm ready for the parent name. I'm running out of room. Cyclobutane. Or 1-bromo, 3-sec-butyl cyclobutane, if you know that name.